On June 26, 2026, the Netherlands did something it had never done before in its entire recorded history. The National Weather Service declared a red alert for extreme heat across 8 provinces at once. Not a warning, not a watch, a full red alert, the highest level that exists. And by the end of that day, the thermometer in one Dutch town read 39.4 degrees Celsius. That number broke the national June heat record. Stay until the end, because what happened after this alert is not what most people expected. And scientists are still trying to explain how a country built for rain and wind suddenly became one of the hottest places in Europe. Let's go through exactly what happened. In the days leading up to June 26th, a massive dome of hot air had already been sitting over Western Europe for almost a week. Meteorologists call this an omega block. Picture a giant letter omega drawn in the sky by air pressure patterns. On both sides, low-pressure systems act like walls, trapping a mass of hot, dry air from North Africa directly in the middle. That trapped air has nowhere to go. It just keeps heating up day after day like an oven with the door sealed shut.
By the time this heat mass reached the Netherlands, temperatures across the country had already been climbing for days. Dutch cities that normally sit comfortably in the low 20s during June suddenly saw readings above 35 degrees. The National Weather Service, KNMI, does not issue red alerts easily. In the history of Dutch weather forecasting, this level of warning for heat had essentially never been triggered at a national scale before. When it finally was, in 8 provinces simultaneously, emergency services braced for what they called a public health event, not just a weather event. Hospitals in several regions reported a sharp rise in heat-related emergency calls within 24 hours. Elderly residents, far more vulnerable to extreme heat, were the focus of public health warnings, urging people to check on neighbors living alone. Employers allowed remote work wherever possible. Outdoor construction paused in some municipalities. Public swimming areas saw record crowds in a country where less than 1/10 of homes have air conditioning. That last detail matters more than people realize. Most Dutch homes were built to trap heat, not release it. Thick insulation, small windows, dense city layouts designed for a cold, wet climate. When a heat wave like this arrives, those same buildings that keep out winter cold become traps that hold in summer heat, sometimes making indoor temperatures at night even more dangerous than outdoor temperatures during the day.
And this was not an isolated Dutch event. At the very same time, similar records were falling across the continent. Germany recorded a new national high near its Polish border. The Czech Republic logged the hottest temperature ever measured in its official station network. Poland broke a record that had stood for more than 100 years. This was not one country having a bad week. This was a continental-scale heat event. And the Netherlands, a country almost defined by its relationship with water and rain, had just become part of the story in the most unexpected way. Scientists who study extreme weather immediately began asking the obvious question: how does a maritime, temperate climate zone produce a national heat record like this, so early in the summer, and so far above anything in the historical record? The early answer pointed to unusually warm sea surface temperatures, pushing moist, hot air further north than these systems typically travel, combined with the same blocking pattern that had already been baking Spain and France for days. There was also an economic ripple most people never connected to the heat. Electricity demand spiked as fans and the small number of existing air conditioners ran nonstop.
Farmers in the eastern Netherlands began reporting extreme stress on crops that had barely recovered from an earlier heat wave in May. Soil moisture levels dropped further, warning of reduced yields. This wasn't just a few uncomfortable days at the beach. It was a stacked event, pushing the country towards severe drought conditions. But here's what genuinely worried climate researchers. It wasn't the 39.4-degree number itself. It was the calendar. This was the third major heat event to hit Western Europe in barely 2 months. Normally, land, rivers, and groundwater get weeks, sometimes months, to recover between extreme heat events. This time, the ground never really cooled down. Western Europe was essentially absorbing heat wave after heat wave with almost no recovery window in between. To understand why that matters, we have to look back to the historic summer of 2003. The uncomfortable truth researchers are now facing is that events resembling the 2003 disaster are no longer rare. They're becoming a regular part of the European summer. The difference is frequency. In 2003, that kind of extreme heat came once. In 2026, similar patterns formed 3 separate times before summer was even half over. Meteorologists say the heat dome sitting over Western Europe is expected to hold its structure, threatening to challenge all-time records. What makes this story worth watching isn't really about one temperature record. It's about what happens to an entire region built around a mild, wet climate when that climate stops behaving the way it always has. Adapting infrastructure, homes, and public health systems built for a cold climate doesn't happen overnight, and it doesn't happen cheaply either.